Hi, I'm Sherman Snyder, Mastercam AE out of the Houston, Texas area for MLC CAD Systems. And today we're going to be talking about the Unified Toolpath and Blade Expert within Mastercam. The Unified Toolpath does have some new selection features as of 2025, and we will also talk about the tool axis control, then move along to Blade Expert and how it streamlines the process of roughing and finishing. So let's go ahead and get started. Right now we see the impeller on my screen, and I have a few things already loaded here. We can see that I already have the round bar stock loaded as a stock model. This stock model will be used whenever we start creating processes. To start our processes, I'm actually going to use the area rough operation found underneath the 3D toolpaths, and we're going to be finishing and roughing off of these faces first. So the first thing I'm going to do is go ahead and select my machining region, and let's zoom in and catch that little area here as well. And we can end our selection. I'm going to select the boundary as well, and we'll green check, and I'm going to set this to the center of my tool here for the compensation. And let's select our 3-inch high feed mill. I like comments, so I'm going to go ahead and give this a comment of rough profile. From here, we'll go ahead and set some feeds and speeds. And I'll tell you what, let's change this to a feed rate that's a little more reasonable for a feed mill. Next, we're going to go over to our cut parameters. And I'm going to set this to climb mill, but let's give it a step down that's a little more reasonable for the feed mill as well. And under our linking parameters, I'm going to give it my typical 1-inch clearance that I like. And let's look at our lead in and lead outs. I want to adjust my lead in to be horizontal. I'm going to give this a radius entry of 1 inch. And I'll do the same thing for my secondary leads as well. Let's not forget to adjust our entry motion type. I actually want to ramp into my part as we go around the outside. And we'll green check, and I'll say OK to this for my boundary on the surfaces here. And we'll let this go ahead and generate. So now you can see my entry that we've adjusted on the back side here. Let's go ahead and move the operation where it needs to be under my 3D toolpaths. And let's move this down for my unified toolpath example that we're about to cover. So I actually want to start by creating a stock model. And this stock model is going to represent the after rough. And we'll pull the information from our stock setup. This stock setup is driven by the stock setup options here. And then we need to tell it what toolpath is being taken away. So we're going to select our rough profile. Once this generates, if I zoom in, we can actually see the step downs from our rough operation. Let's go ahead and create our unified toolpath. Under the Unified Toolpath, I'm going to select my ball end mill, and I'm going to give this a comment of Unified Finish. We're going to look at the cut pattern now, and we'll start by selecting our machining surfaces once again. You'll notice that above that we have different pattern selections that we can choose from. The very first one that we have in the list is automatic, and automatic does give some basic functions such as parallel. Let's green check and see what this looks like. So it's not quite giving me what I want, but the good thing about the Unified Toolpath is I can always go in there and make some adjustments. You see the radius there doesn't look too bad. Under the parameters here for the style, I'm going to change this to a morph. Now in this case, it's most likely going to give me something automatic. Might like it, might not. But the good thing again, we can always go back and make some adjustments to this. Let's go ahead and remove these options that we have here. So I'm going to start by clicking on the X. And this time I'm actually going to drive between curves. Let's select the morph operation for this example. And you'll notice that automatically, because it's a morph, we get two different curves that we need to select. As we see here, there's no entities. So let's select our top entity first. And let's select the secondary entity. Let's flip this around. And we'll green check. So as we see here, I'm going to minimize this dialog. And you see that we have the green surface. This is our machining region, as well as the blue curve up top and the yellow curve at the bottom. That represents our cut patterns. As we can see here, my machining region is green. And then just above this in my patterns, we have a curve that's blue and yellow. Let's change this to a spiral operation as well. I don't want to zigzag back and forth. And just for an example, I'm actually going to cut the opposite direction, whether it's conventional or let's look at the clockwise and counterclockwise options. I'll leave it for counterclockwise for the time being. And we'll also look at our step over. So our step over is driven by the scallop height. They are linked together. As we can see here, if I change one, the other changes as well. I'm going to leave this for the 1 thou scallop height. There's more options to talk about underneath our toolpath control for our tool axis. And I'm going to set this for 3-axis about my WCS-Z. As we can see here at the bottom left corner, this is going to be about the Z-axis for our tool axis control. For now, let's go ahead and see what this looks like. I'm going to look at my multi-threading manager here, and this is going to allow me to see the process of the operation as it generates there. And let's run this through backplot. I'll start by pressing play, and we can see here that my tool remains in the same Z axis. So let's green check OK on this, and we're going to open up our parameters once again. Inside of our parameters, let's go ahead and correct the direction. And we can go back to our backplot here in a second. And let's wait for it to process. Green check. And let's look at the backplot here. So now we can see that we are actually going the proper direction. Of course, we want to climb mill on a CNC in most cases. But let's take a look at some of these other parameters that we have. Underneath our tool axis control, I can also set this to a 4-axis operation. And for now, I'll leave this with surface for a tilt, but there is a lot of other options there as well. For the 4th axis control, I need to correct the direction that we are actually tilting about. And just like I mentioned before, we have our WCS in the bottom left corner, Z pointing up. So I want to correct this to follow that Z WCS. We're going to point towards the rotary axis, but underneath this, we have the option to actually push our tool over to the side, as we can watch this little dialog to the right. You can see this option will push the tool to the right off the center. And then we have our other angle, which will tilt the tool at the given angle that we put in. I'll give it a 45 degree. Let's green check on this. And we'll let this generate. And once this generates, we'll actually run it through our back plotter as well so we can see the actual angle of the tool. In this case, let's use our simulation. I think it's a little more fun when we actually see the machine running, right? So once the simulation loads, Mastercam will take the NCI or the operations and run these through the actual machine itself. And I'll go ahead and let this rough out. Let's speed it up a little bit here. And we'll get down to the bottom. And now we can see that fixed 45 degree that we have in place. Notice that the bed here is going to be the only thing advancing. As we zoom in, you'll notice that the distance between the actual trunnion and the machine itself does not move. So it's only advancing forward in the y-axis. This is going to be due to the lock that we have at that 45 degree. This is keeping it at a 4-axis operation. So I'm going to close this down and we'll make a couple more adjustments under this unified toolpath. Under the tool axis control, we'll set this to 5-axis. I'm simply going to drive this to a surface right now. And I like seeing my multi-threading manager here. Just kind of gives me a percentage of what my process is doing as it generates. In green check. And let's just backplot this one here. And one thing I notice is that tool is tilting pretty major here. The last thing I want to do is have my table kick up like this towards my spindle. But as you can see, as we go around the part, the tool is following the surface. And I actually want to limit how much it's tilting. And being that we already have a boundary curve above, we'll go ahead and take advantage of this boundary curve that we use for our roughing operation. So let's green check and go back to our parameters. Under the 5-axis, we're going to set this to use a from chain here. This chain requires a selection. We can also use tilt angles, etc. But let's just make a simple selection of this curve above. This is going to be our from chain. And let's go ahead and green check. So once this processes, we're going to take a look at how the holder itself, or the axis of the tool, will follow this chain under our backplot here. Let's go ahead and stop this and I'll rotate it. As our tool goes down, it doesn't matter where on that holder, but in line with the tool itself. As you can see, our tool will always follow that from chain. This will limit the tilt so we're not tilting closer to our table or having the trunnion kick up towards our spindle. There's a couple other options I want to adjust under my linking parameters. As of right now, you can see I got a pretty good tool path, but I want to adjust these options here for my first and last entry as we're spiraling down. And please pay attention to the options under the left as we change the lead in here. You can see my first entry lead in has been added. And if I go do this to the exit, you will see that there's a last exit as well. Now by default, if I was to look at the first entry, you can see that these follow the default lead in and outs. We can go ahead and take a look at these defaults right now. I'm going to adjust this arc to be 0.5, and let's just go ahead and copy these over for my exit as well for the lead out. Underneath this, I also like to adjust my plane, so I'm going to set this to a z-axis, about that WCS again, and we'll set this for just a few inches above our part. We'll green check OK. As this process generates, we'll see the status as it climbs here. Alright, everything looks good. We have our entry and exit now. Starting with the entry, and then of course the radial exit coming off. We also have that plane that we put above our part for the 3 inches. So I'm going to go ahead and zoom out here a little bit. And let's actually select all our operations. I want to actually simulate this as well. So let's run this simulation here. Under the simulation, as the part tilts around, this will give us a better visual of what's actually happening on the machine. So we'll go ahead and bypass the roughing here. I'll just speed it up a little bit. And now we'll slow it down and kind of zoom in a little bit here. And what you'll notice here is that the table, the trunnion, is actually tilting gradually as it advances forward. What you're also going to see is the y-axis still advance forward at the same time, giving us a true 5-axis operation. So we see that it starts to close the gap. So once we kind of zoom out a little bit here, I'll go ahead and speed this up. And you can get a better visual of that part advancing forward as we see the gap starts to close. So let's close this out. And let's look at the rest of our part actually. We have our unified toolpath. We can see the morph operation. We can also choose between any other guide style curves, project as well if we need to make changes. But I like the toolpath. So we're going to advance forward to actually machining the blades of this impeller. And to do the blades, we're going to use an add-in inside of Mastercam called Blade Expert to machine this region. And I've colored the faces just to kind of give everybody a little bit better visual of what we're machining here. Under the Blade Expert add-in, we're going to start by giving it a comment. We'll call this rough between blades. And let's select our bullnose end mill here. Next, we have to select a cut pattern. We have to tell Mastercam how we want to cut, whether we want roughing, finishing, etc. For this, I'm going to offset from the hub. So my tool pass will be coming from the hub going upwards on this blade to the left. And we're going to take a look at some of the other options that we have here. I want to keep this for zigzag. I actually like the order at which we're cutting. So let's look at our part definition. And right now we have to define our blades. So we can see here we have color options as well. Let's select the inner portion of the blades that we're going to machine. So I'll start here, select the left side, and we can end our selection. Now we don't have any fillets, but I do need to select the hub. I need to tell Mastercam where the hub is at between the blades. And we can end our selection here as well. If needed, there are other options, but let's green check OK. And we'll look at the multi-threading manager right now. With the Blade Expert add-in, Mastercam automatically tilts the tool as needed to get the maximum area of cut on our part. Now this is designed to be able to cut all the other blades as well. And typically what we would do in the past is go to Toolpaths. Under the Toolpaths tab, Utilities group, we would transform the toolpath, right? We're not going to do that here. Let's go back to our parameters. Right now, we're going to tell Mastercam how many segments we have. But there's an option that we're also going to have to adjust as well. We'll come back to that. Right now, Mastercam knows that we have 9 segments. So, with these 9 segments, what we're actually going to see without the other adjustment is Mastercam just knows those 9 segments are there. We still have it set for doing 1 segment. Underneath this, we could tell it how many of these segments we want to machine as well. So it knows we have 9 segments. Let's go ahead and give it a value of 9 to machine all segments here. With that in mind, we can also do partial parts as well if we need to do 90 degrees or maybe 180 degrees of this part. As this processes, let's go ahead and green check after this is done, and we'll be able to see all 9 segments being done all in one shot without a toolpath transformation, which also means that we get the nice blend between one segment of blades to the next. The good thing about the Blade Expert add-in is I can actually copy this afterwards. Now, with copying, Mastercam will already have the selection of my blades done, such as the blade faces, the hub, etc. When copying this toolpath, everything inside of Mastercam is still reading the original segment, so it's taking a little bit of time, but we'll go ahead and adjust this as well. Inside of the parameters, we're going to make some adjustments to our cut pattern. Instead of roughing between the blades, let's do the finishing of the floors. So we'll select our hub here. Now I can tell it from left to right, right to left, but I actually like to start in the center of my blades and work towards the wall. Makes it a little easier on my tool as we approach the walls coming from the center going outwards. And we'll have it set for climb milling as well. So we're simply going to green check OK on this. Right now, you see that we still get the 9 segments because that setting was already set. We also start from the center and we work our way out, starting from the center of the blade. And of course, Mastercam's giving us the tilt values that we need. Let's copy this next operation. Just to clear things up, let's rename these processes. And I didn't mean to hit enter, so we'll go back. It's no big deal. And let's label this one finish hub. And let's do the other one as well for finish blades. Let's adjust the parameters for the finished blades. Under cut pattern, we're going to set this for blade finishing. I'm going to do this as a pocket so we can go in between our blades there, right down the middle, just like we see here. And we can make other adjustments as needed. I'm going to keep this for the defaults. Under the cut pattern, you can see that I still have the same machining definition, the part definition selected. So we'll green check. And it's letting me know that I need something with a spherical tool, so we can correct this by selecting the ball nose end mill for the finishing here. We can also use tapered end mills and barrel mills, etc. As we see here, we have our blade finishing. Let me correct the bull nose here as well for my finish of the hub. So we're matching our finishing tool here. And we'll move this down to the bottom. I'll minimize everything just to make it a little more clear on my screen. And save. One thing I say quite often is save is your friend, so it just depends on how much you want to lose. So let's go ahead and run this through our simulator. Now there's a lot more going on in this part, more specifically with the roughing. But I at least want to see a portion of this being simulated here on the machine. Typically when I'm processing a job like this for my machine, I'll watch the whole thing process through just to make sure that all my tilts and any kind of tool clearances actually are not being violated, whether it's with my part or with the machine in general. Let's just make sure that I have this running. All right. All right. So it's preparing the simulation data. I believe I hit that twice. So let's see. Okay, I did. So we'll just say okay to that as it was processing the simulation to begin with. And I'm going to zoom out and we'll just simply hit play on this. And let's speed up this rough a little bit. And let's go right to the finishing of the outside. You can see our nice tilt here. And let's speed this up so the tool starts to climb down the bottom just for the finishing of the OD. This is great if you don't have a lathe and you need to finish the outside. So once the finishing of the outside is done, we can see that we have a real nice clearance. There's no red of the chuck hitting the spindle. We can swap our tools and we can come in with that bullnose end mill, roughing out the outside. This is going to allow us to see if there's any kind of collisions as the table moves around. Now, being that this does take a moment, I've taken the time to just put aside a quick verify here so we could take a look at what this process looks like when it's finishing. Let's take a moment to look at that here on my next screen. So as we can see here, we have the finishing of the blades, the floor, as well as the rough operation being done in one shot.